Alright, welcome to this video. Just a quick one on compound interest, which as you can see is just interest that's paid on the principal, and essentially they add the amount of interest that has been earned into the principal every so often, so your money grows just that much faster. I mean, it doesn't have to be money, but it's almost always money with these problems. The formula is explained here with all the parts. A is the amount after T years. P is the principal amount invested. R is the annual interest rate. And then N is the number of compounding periods each year. The one thing I would say is occasionally there will be a problem where T maybe is not in years, right? T could not be years in some problems, and you just use T as the time period. It could be any time period. And in that case, N would be just some partition, right? Some partition of that time period. So you could think of it maybe T could be an hour, and if your bacteria is compounding or your money is compounding every minute, you could use N could be a minute. So that would be 60 for that one, and T would be the number of hours. Just going to do a quick example here. Essentially, it's pretty laid out. You'll know to use compound interest in any word problem because it'll say interest and compounded and time period of it being compounded. So let's just take a look at this one. An investment account pays 4.2 annual interest. So R is equal to 0.042. Got to move that decimal place over twice, right, to put it into numerical rather than percentage. The annual interest, so that's yearly, right? T is in years. Compounded monthly. So N is the number of times compounded monthly. There's 12 months in a year. 2,500 is invested. That would be the original investment. So P is going to be equal to 2,500, and I want to know the balance after 15 years. So T in the problem is going to be 15 because it's been 15 years, and I have everything I need to set this up. And that's essentially how any compound interest problem is going to work for you. So A is what I want to know. P is 2,500. Big parentheses, 1 plus 0.042 over 12 for the months to the, and be careful when you type this part into a calculator, to the 12 times 15. Make sure you multiply those things together in the exponents. And then we just go for it. So we'll start with 0.042 divided by 12, and we get 0.0035, and we're going to add 1 to that. So A is equal to, I know I didn't really need to use the calculator for that, so 1.0035. And we'll go ahead and do 12 times 15 as well, and we get 180. So A is equal to 1.0035 to the 180th, right? Still a pretty small number. So 2500 multiplied by 1.8755 right? Because I'm not going to take it out of the calculator, times 2500. And we get our amount after so much time as 4,688.86. This is money, so you should round it right? Just to the hundredths place for pennies. Good.